Hello guys, welcome to another calculus video. This one's going to be a bit of a long one. Today we're talking about finding extrema. So this is stuff like relative minimums and maximums. This is going to be super important and it's one of the main applications of derivatives. So let's get started. Okay, so here we're going to talk about how we're going to do this. In the blue we have f prime of x, and in the red we just have f of x. So this is f of x and this is f prime of x. So what we're looking for is relative maximums and minimums. So that's points like this. This is a relative min. This is a relative max. Okay, so how can we figure this out? Well, one thing that we can see here is if we look at the slope at the relative minimum, we can see that it makes a horizontal line, which means that the slope is 0. And lo and behold, f prime of x at that point is also 0. Also at this point, slope is 0, f prime of x is 0. So what this means is that we have to figure out when we just set f prime of x to 0, and that tells us where our critical points are, as we call them. Points that make the derivative 0, that's called a critical point. Okay, now here's the problem. When we figure out that f prime of x is 0, how do we figure out if it's a relative minimum or maximum? Well, here's how we do it. As you can see, if we follow the curve of f of x, it's increasing, 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 increasing. Now it's at this point it's technically constant, then it's decreasing, 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 decreasing. So f of x goes from increasing to decreasing. So that means that f prime of x goes from positive at some point, positive, 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 then it goes to 0, we know at this point, and it goes to negative, 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 because the slope here is negative, right? So what we know is that at a relative maximum, f prime of x is decreasing. Well, how can we figure out if f prime of x is decreasing? Well, at a relative maximum, since f prime of x is decreasing, that means that f double prime of x, which we're going to talk about in a moment, is going to be less than 0. And the same thing applies for relative minimums. At this point, it's decreasing, 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 and then increasing, which means that f prime of x, so at a relative min, f prime of x is increasing. Okay, now let's talk about what is a second derivative, because that probably was just a lot of stuff that you didn't understand. Okay, second derivatives. So second derivative, pretty straightforward, is just the derivative of the derivative. Now that sounds a little bit dumb, but it just means that when we differentiate f prime of x, we get f double prime of x. Now we can keep doing this process. We can do differentiate double prime of x and get triple prime of x. Just keep tacking on a prime, but this isn't very helpful to us. Mostly we're going to use this one, and most of all this one, of course. So how to get the f double prime of x? All you have to do is perform the same functions for differentiation on f prime of x. So just do whatever derivative rules you would usually and find out double prime of x. And the reason this is helpful is because if f double prime of x is greater than 0, this means that f prime of x is increasing. And this means that if f double prime of x is less than 0, f prime of x is decreasing. And so that leads to what we talked about on the last slide, where we can figure out that the relative minimums and maximums are depending on f double prime of x. So let's go over steps one more time. First, we find f prime of x equals 0. Then if f double prime of x is greater than 0, we have a minimum. And if f double prime of x is less than 0, we have a max. Okay, let's go solve some problems. So this is our first problem. We're just going to go ahead and find f prime of x and f double prime of x just to start. So f prime of x is going to be, looks like x squared minus 6x plus 4. f double prime of x, we're just going to differentiate this. It's going to be 2x minus 6. Okay, so we want to set this equal to 0. This is f prime of x, and that's going to give us the points that we're going to be checking, and then we're going to use f double prime of x to figure out whether they're minimums or maximums. So x squared minus 6x plus 4 equals 0. I'm just going to go ahead and solve this. X minus 3 squared plus 4 minus 9, or minus 9 equals 0. So x minus 3 squared equals 5, and x equals 3 plus or minus square root of 5. I just did a real quick completing the square there. I don't know if you followed, but that's just what I did. And so now we're going to plug these into our f prime of x. So f prime prime of 3 plus square root of 5 is 6 plus 2 square root of 5 minus 6. These cancel. 2 square root of 5 is greater than 0, which means that 3 plus square root of 5 is going to be a minimum. This is a relative minimum. And if we plug in f double prime of x at 3 minus square root of 5, as you can imagine, this is going to be 6 minus 2 square root of 5 minus 6. 6's are going to cancel. This is less than 0. So x equals 3 minus square root of 5 is going to be a relative maximum. Okay, let's move on to the next question. Okay, f of x equals sine of 2x, and we're going to find all the relative extrema on 0 to pi. So f prime of x is going to be 2 cosine of 2x, and f double prime of x is going to be negative 4 sine of 2x. Okay. Now let's solve. We'll set this equal to 0. This means that cosine of 2x equals 0, which means that 2x equals pi over 2 plus pi n, or x equals pi over 4 plus pi over 2n. And since we're using a closed interval here, I'm just going to go ahead and write out all the possible answers. So we have pi over 4, 3 pi over 4, and if we add one more pi over 2, we're going to be past our limit of our domain restriction, so we're just going to worry about these two. Now let's plug them into f double prime of x. So f double prime of x, f double prime of pi over 4 is negative 4 sine of pi over 2, which is just 1, so this is just negative 4, is less than 0. So pi over 4 is a relative max, and f double prime of 3 pi over 4 is going to be negative 4 times sine of 3 pi over 2, which is negative 1, which means we're going to have 4, which is greater than 0. So 3 pi over 4 is a relative minimum. And that's our answer. Okay, next question. So now we have f of x equals secant of x. We're going to find all the relative extrema between 0 and 2 pi. So f prime of x is going to be secant x tangent x. F double prime of x, we're going to use the product rule. We're just going to say secant x times secant squared of x is secant cubed of x. And tangent x times secant x tangent of x is secant of x tangent squared of x. This is a square. So we're just going to factor out secant x. Okay. Now we're going to solve. Now secant of x is never equal to 0. So we're just not going to worry about that. We're just going to say tangent of x equals 0, which means that x equals 0, pi, and 2 pi, but as you can see, 2 pi is outside of our domain because we have open parentheses, so we're only going to worry about 0 and pi. So when we plug in 0 into f prime prime of x, we're going to get 1 times 1 plus 0 is 1 is greater than 0, so x equals 0 is a relative minimum. And if we plug in pi, f prime prime of pi is -1 times 1 plus 0, which is equal to -1, which is less than 0. So x equals pi is a relative max. Okay, 2 more problems. Okay, now we have just another polynomial here. Oh, you're kidding me. Just don't worry about this. We're going to find all the relative extrema. Don't worry about this domain restriction. That's just left over from the last problem. So f prime of x is going to be equal to 3x squared minus 6x minus 24. And f prime prime of x is going to equal 6x minus 6. Okay. Now let's solve for f prime of x equals 0. So I'm going to just divide by 3 everywhere. So x squared minus 2x minus 8 equals 0. We're just going to factor this. X minus 4, x plus 2 equals 0. So we have x equals 4 and x equals -2. Now we're going to plug it into f double prime of x. So f double prime of 4, that's going to be 24 minus 6 is 18, which is greater than 0. So x equals 4 is a relative min. And f double prime of -2 is going to be -12 minus 6 is -18, which is less than 0. So x equals -2 is a relative max. Alright, one more problem. Okay, this one's going to be a little bit more complicated, but let's just go through it step by step. So we're going to solve for f prime of x. So we're going to use product rule. So we're going to have f prime g, which is going to be 2x plus 1 times e to the x, plus g prime f, that's going to be x squared plus x minus 1, which is the same as we're just going to combine everything here, e to the x squared plus 3x, and these ones are going to cancel. Okay, so f double prime of x, we're going to do the exact same thing. So f prime g, e to the x times x squared plus 3x, plus g prime f, x plus 3 times e to the x. I'm going to say e to the x times x squared plus 5x plus 3. Okay. I'm going to set this side equal to 0, and e to the x is never 0, so we don't need to worry about that. X squared plus 3x equals 0. We're going to have x times x plus 3 equals 0, or x equals 0, x equals -3. Okay, now let's plug that into f prime prime. So f prime prime of 0, that's going to be 1 times 1 plus 3 equals 4 is greater than 0. So x equals 0 is a relative min. Then f double prime of -3, that's going to be e to the -3rd times 9 minus 15 plus 3, e to the -3, this is going to be -3, which means that this is going to be less than 0, and x equals -3 is a relative maximum. Okay, that's the last problem for this video. I hope you guys found it helpful. I know this was kind of a big video. We went over second derivatives and relative extrema in just a few minutes, but I hope you found this helpful. I'll see you in the next one, and we'll definitely see problems like this again. Bye!